Let's start exercises 6.3 next, and this is the second one. X and y are any two real numbers. For them, we have to prove a number of properties of the greatest integer function. The first one is this: the greatest integer value of x plus n equals the greatest integer value of x plus n for any integer n. There are other properties also, but let us first prove this one. So we start the solution like this by considering the greatest integer value of x plus n. This is something we already know about the greatest integer function. In fact, this comes directly from the definition itself. The greatest integer value of x plus n is the greatest integer less than or equal to x plus n. So from there itself you get this first inequality, and because this is the greatest less than or equal to x plus n, the next greater integer which you obtain by adding 1 to it will not be less than or equal to x plus n. So that's why this one is strictly greater than x plus n. Alright. And then what we do, we subtract n throughout, thereby obtaining this greatest integer value of x plus n minus n less than or equal to x, because if you subtract n from x plus n, you get x, that is less than this minus n. We write the minus n first, plus 1, and then we note this thing: since the greatest integer value of x is the unique integer satisfying these inequalities, that is, it is less than or equal to x and x is less than it plus 1. So that is why this would be equal to this. Why? Because if you look at it carefully, this is an integer. This is already an integer from which you are subtracting n, which itself is an integer. So obviously this is an integer which is less than or equal to x, and x is less than this plus 1. But here we are saying that this by definition is the only integer, the unique integer satisfying exactly same inequalities. So obviously this has to be equal to this. Now you add n to both sides, and that gives you this first identity. The next property is this, part B, where we have to prove that the sum of the greatest integer values of x and minus x, okay, greatest integer x plus greatest integer minus x is 0 or minus 1 according as x is an integer or not. That means if x is an integer, then this will be 0, otherwise it will be minus 1. The first part of the solution is almost trivial, which is the case where x is an integer. If x is an integer, then so is minus x, it's also an integer, and in this case both this and this are themselves in the sense that this is x and this is minus x, which obviously is 0. Now we are going to consider the second case where x is not an integer. So we next assume that x is not an integer. Then x can be written like this: the greatest integer value of x plus theta, where theta is a real number lying between 0 and 1 in this manner. Theta is positive and is less than 1. Actually this theta is nothing but x minus the greatest integer value of x. Alright, now what can you write in place of minus x? Because x is this, minus x will be minus the greatest integer value of x minus theta. But we additionally write minus 1 plus 1, that we can do. And where we also note that because of these inequalities, 1 minus theta also satisfies the same inequalities. 1 minus theta is greater than 0 because theta is less than 1, and 1 minus theta is less than 1 because theta is greater than 0. Alright. But now what does this part imply? It implies that minus the greatest integer value of x minus 1 is less than minus x. Why? That is because minus x is this thing plus 1 minus theta, and 1 minus theta is positive. So that means minus x is larger than minus greatest integer value of x minus 1, which is what we wrote here. but at the same time, because this part 1 minus theta is less than 1, so if in place of 1 minus theta we write 1, that means we are writing more, so that is why minus x is less than this plus 1, which turns out to be equal to just minus the greatest integer value of x. Now you see carefully that this minus greatest integer x minus 1 is an integer and minus greatest integer x is also an integer, in fact the next one, and between them minus x is trapped. So by the definition of the greatest integer value of minus x, that will be equal to this. And now next what you do, there is only one more thing to do, you add greatest integer value of x on both sides. So that way you will get greatest integer x plus greatest integer of minus x equal to minus 1. That's what we wanted to show. Next let us see part C, where we have to prove that the sum of the greatest integer values of x and y is less than or equal to the greatest integer value of their sum x plus y. And additionally, if x and y are both positive, then the product of their greatest integer values is less than or equal to the greatest integer value of their product. So we start the solution by adding these two inequalities, this one and that one, which of course we already know that the greatest integer value of x is less than or equal to x, similarly for y. So doing the addition, this is what we get. The greatest integer value of x plus the greatest integer value of y is less than or equal to x plus y. Now we recall the definition of this. By definition, this quantity is the greatest integer less than or equal to the real number x plus y. Okay. But what do we see here? That this greatest integer x plus greatest integer y is another integer which is also less than or equal to x plus y, because this is the greatest among all such integers which satisfy this inequality. So obviously this will be greater than or equal to this some other possibly different integer. This may be equal to this, but this may be strictly greater than this as well. So that is how we have the first inequality. And now we will go for the second one, where there is a condition that x and y are both positive. So for this second part, we start by writing the condition first, that x and y are both positive. That means besides having these two inequalities, we now also have the information that these greatest integer values are non-negative, greater than or equal to 0. Why? What does it mean for x to be positive? That x is greater than 0. Okay. So already 0 is an integer which is less than x. Now the greatest integer value of x is by definition an integer less than or equal to x, and it's the greatest of that type of integers. 0 is one such integer. So that greatest nature of this will make it greater than or equal to 0. It may be equal to 0, but it may be greater than 0 as well. Similarly, we have this. Now because we are dealing with 4 non-negative real numbers, that is why we can multiply these two inequalities, and that will give us this fact, that greatest integer x times greatest integer y is less than or equal to xy. Without non-negativity, we cannot multiply. I mean, of course you can do, but then you won't know which way the inequality will go. But now we can, and that gives us this. And then you have to proceed similar to what we did here. So this part I am leaving to you. There are other parts also to this exercise which we will solve in the next video.